Session. This is Kent. He's the 12:15, but we're starting at 12:20, a few minutes late. The thesis is Kent's was a pretty interesting topic. It sort of bounced around a little bit and changed directions a little bit at times through the year. But it was always interesting to talk to Kent about his ideas. Kent's words are, I would like to thank God for all the good he has done and the blessings he has given in my life, and for giving me the chance to speak in front of everyone today, as without God I'm nothing, and without God I would not have been able to complete my thesis. For Mr. Wade, for his patience, and for not crashing out during class because I submitted my thesis drafts 1 month late from the checkpoint, as I gave him terrible flashbacks to the time I was in 8th grade. That's true. And for believing in all of us that we can finish the thesis, even though I didn't even believe in myself that I was able to do it. For Mr. Christian, for being my helpful and patient advisor and guiding me through this topic and dealing with my every question when I asked him, even though some of my questions were stupid and repetitive, and I asked for advice at the wrong time. For my friends, for helping me complete this thesis and their support along the way, specifically to Darren, who helped me revise my thesis and use stronger words. To myself, thanks himself. And finally, number 6, thank you to Persib Bandung for making me happy and almost winning the league Persib Juara.
We're winning it this year.
All right, Kent's title is, If It Ain't Broke, Don't Fix It. Why synthetic fuels and biofuels are the best options for green, eco-friendly cars. Let me get the timer set up. I'll tell you when you can start. All right, you can start whenever you're ready.
Can I see the timer?
I will turn it around as you talk.
I need to compose myself. Sorry.
Just take your time. Start whenever you're ready.
The year is 2045. The skies are blue and clear. You go on your road trip as you enjoy the fresh air of the toll road. You're going to the beach and fuel is running low. So, naturally, you go to a gas station and fill up with gas. And just in a while, you are done. You continue the trip without a worry in your mind, enjoying the fresh air for the first time in years. In the middle of the road trip, you stop for a rest. As you rest, you enjoy the view of clean skies and of green, lush fields which stretch for miles, filled with the fresh smell of the earth and flourishing with life. Wait, this does not sound right. We all are still using internal combustion engines, right? Where are all the electric cars? Where are the long queues at the charging stations? Don't we need electric cars to enjoy such an idealistic future like this? Well, let me tell you, we do not, as this is possible with biofuels and synthetic fuels. No long queues in charging stations or range anxiety during long trips. These fuels promote the benefits of the internal combustion engine while suppressing its disadvantages, allowing us to enjoy an idealistic future without any carbon emissions. Global biofuel consumption accounted for 4.3% of global energy consumption in the year of 2022. The biofuel sector in itself accounted for 51% of all alternative fuel resources used in 2022. Meanwhile, synthetic fuels have also been extensively researched, tested, and proven to work on normal cars without any major modifications. Synthetic fuels have also been used in motorsports such as Formula 1 and Formula 2 without major performance issues for the vehicles. To clarify, biofuels are fuels derive either directly or indirectly from biomass, which, unlike petroleum, takes a short time to produce. Synthetic fuels refer to electrofuels, which are produced by the combination of hydrogen atoms through the process of electrolysis from water and recycled CO2 gas. Synthetic fuels, in this case, does not include synthetic fuels that are produced from coal. This speech will only talk about the use of synthetic fuels in cars, trucks, and motorcycles. As we all know, carbon emissions causes climate change, extreme weather events, change the behavior of animals, and they damage human health. These consequences from carbon emissions cannot be ignored. There are multiple options for resolving this issue. However, the best option for a carbon neutral future will be the use of synthetic and biofuels. These fuels are carbon neutral and are better than electric cars. Synthetic fuels and biofuels should be considered as a carbon-free alternative to electric cars due to their economic, environmental, and practical benefits. The first reason that biofuels and synthetic fuels should be considered as a carbon-free alternative to the electric car is that biofuels and synthetic fuels provide more economical benefits compared to the electric car. For one reason, trillions of dollars are needed to be spent on infrastructure that can support electric vehicles. Meanwhile, for biofuels and synthetic fuels, the infrastructure for these fuels are already there. Europe needs 280 billion euros every year in investment for its electric charging infrastructure in order to reach its goal of having a total of 6.8 million chargers by the year of 2030. Despite huge investments, however, EV infrastructure continues to remain insufficient to meet EV demands. Meanwhile, infrastructure catering towards gasoline cars have been there for decades and is compatible with green biofuels and synthetic fuels, avoiding the need for additional investments. With synthetic and biofuels, the infrastructure that already exists could still be put to good use. Through the adoption of biofuels and synthetic fuels, trillions of dollars could be saved, thanks to the fact that biofuels and synthetic fuels rely on existing infrastructure. Other than that, the adoption of biofuels and synthetic fuel will preserve the already existing value of the internal combustion engine cars. Abandoning technological developments and the cars themselves is a huge waste of resources. There's a total of around 1.47 billion cars in the world, most of which are still equipped with the internal combustion engines. Even though EVs have taken a hold of the car markets, most cars that are sold in the world in this year still use internal combustion engines, which is 86% of all cars sold right now still using internal combustion engines. Just imagine we throw away 1 billion cars just we can convert to electric vehicles. It's very wasteful. By adopting synthetic and biofuels, the value of gasoline cars and petroleum infrastructure could be preserved. Another issue in electric car research and development is that the research and development and production consume trillions of dollars. Lots of companies suffer from financial loss while researching electric cars. In 2024, China's largest electric car manufacturer, BYD, research and development costs caused it to record a record loss of $10 billion. Much less money will be required to research and develop vehicles that run on biofuels and synthetic fuels, as the research already exists with real-world proof. The country of Brazil, for example, has already adopted biofuel as a main fuel source and has saved money from that investment by importing less fossil fuels. E-fuels also utilize old technology, which requires less research than electric cars. Therefore, synthetic and biofuel research will save many car manufacturers trillions of dollars from expensive electric car research that often diminishes profit by instead utilizing the technology that already exists that is able to create biofuels and synthetic fuels. The second reason that synthetic fuels and biofuels are better alternatives to electric car is that synthetic fuels and biofuels are more environmentally friendly compared to the electric cars. The production of electric cars, specifically the batteries of electric cars, causes considerable environmental damage. Meanwhile, biofuels and synthetic fuels are much greener in comparison. The rise of the EV market in recent years has increased the demand of batteries, which require rare earth materials like lithium, nickel, and cobalt that needed to be mined. Copious amounts of rare earth minerals are mined in order to satisfy this demand, which causes a lot of environmental damage and release a lot of CO2 gas. Meanwhile, synthetic fuels provide a more environmentally friendly solution than electric cars, as the process of producing synthetic fuels involves taking CO2 from the atmosphere and converting it into usable fuel. Biofuel extraction, which essentially just extracts the plants, has a much cleaner extraction process compared to mining for rare earth minerals. Biofuels also tend to burn cleaner and produce fewer carbon emissions compared to normal fuels. Additionally, plants that are used to make biofuels also help as they absorb CO2 from photosynthesis. Due to this, synthetic and biofuels produce fewer carbon emissions compared to lithium mining. Next, while they can be recycled, most batteries used by electric cars are disposed of, and their careless disposal causes a lot of environmental damage. Meanwhile, components used to make cars that consume synthetic and biofuels are much easier to recycle and are disposed of in a better manner. Out of all lithium-ion batteries, only 1% of all of them are recycled and made into useful materials. The rest are just thrown away and they release toxic waste that harms the environment. Disposed batteries are often burned, which releases CO2 emissions and toxic chemicals into the air. Meanwhile, regular internal combustion cars are easily recycled, with their process being efficient and safe, relatively inexpensive, and producing fairly few emissions. Cars that run on synthetic and biofuels are recycled more easily compared to electric cars and their batteries, and so they are better for the environment. Last, while most biofuels and synthetic fuels come from renewable resources, most of the electricity in the world that is needed to power electric vehicles are still produced with fossil fuels. Most of the electrical energy in the world is not generated from renewable energies. Instead, they are created by burning fossil fuels. On the other hand, synthetic fuel production uses methods that involve the use of renewable energies. Additionally, synthetic fuels are created by taking CO2 from the atmosphere, while biofuels can be made from waste biomass or use sustainable methods, which are ultimately better for the environment. The current generation of electrical energy for the use of electric cars may still be dominated by non-renewable resources, as many countries like Indonesia, for example, are still relying on fossil fuels for their electricity generation. On the other hand, biofuels are made with a renewable process, and synthetic fuels involves taking carbon dioxide itself from the atmosphere and converting it into usable, clean synthetic fuel, leading to a more environmentally friendly alternative to the electric car. A final reason that synthetic and biofuels are better alternatives to electric cars is that the use of synthetic and biofuels is far more practical than switching to entirely electric cars. Electric vehicles often take an eternity to charge, increasing impracticality. Meanwhile, cars using biofuels and synthetic fuels do not take a long time to charge. On average, the electric car takes 2 to 8 hours to charge on slow charging, commonly held in most houses and most charging stations. On fast charging, which is found in some charging stations, they take 20 to 40 minutes to charge to full. Charging electric vehicles takes ages, even in the best case scenario. Compared to refueling a biofueled or synthetically fueled car, it just takes 3 minutes to refuel those cars. Far less time than charging an electric car. The long charging times compared to biofuels and synthetic fuels show that electric cars are far less practical compared to synthetic and biofuels. Next, compared to the production of synthetic and biofuels, electric car battery production is a very impractical process. Batteries used in electric cars require the use of rare earth minerals to function. One of these materials is lithium. Lithium is hard to find in its pure form required to produce batteries. limiting supply to few countries. Shipping the lithium from these few places to the places where it's processed and assembled into batteries costs a lot of money and takes a lot of resources. Lithium is just one of the many other rare earth materials, like I said before, like cobalt and nickel, that are needed to produce batteries. Shipping these materials from their source to the place where they are assembled into batteries takes a lot of effort and money. Meanwhile, materials for biofuels and synthetic fuels are already readily available in each country. Any country can create these fuels with its own resources as long as there exists a place to create them. The production and transport of biofuels and synthetic fuels are much more practical and cheaper compared to the production of electric car batteries. Last, unlike electric cars using synthetic and biofuels, which still has the range of a normal internal combustion engine car, electric cars unfortunately still have terrible range. The range of an electric car is oftentimes dynamic and relies on many external factors outside the car. On average, electric vehicles today have a range of around 398 kilometers. However, most of the electric cars with a range of over 500 kilometers are luxury vehicles that most people simply cannot afford. Most affordable electric vehicles have a range of just around 300 kilometers, which is much lower compared to internal combustion engine cars today. By using synthetic fuels and biofuels instead of switching entirely to electric cars, there is no need to worry about such problems. They work using the same principles as normal internal combustion engine and retain the attributes of the internal combustion engine. Most internal combustion engine cars have ranges that are well over 600 kilometers, even in cheap economical cars. So unlike in electric cars, the use of cars running on synthetic and biofuels would not need to worry about range anxiety. Some people might say that electric cars are easier to maintain compared to vehicles with biofuel or synthetic fuels. After all, they have fewer moving parts compared to vehicles that use biofuels or synthetic fuels, which are essentially old, complicated internal combustion engine vehicles. While some people might view it as easier to maintain electric cars with fewer moving parts and fewer components, maintenance on those vehicles is actually much more difficult than maintenance on vehicles using synthetic and biofuels. Why is this? It's because electric cars use high voltage components. Components with high voltage require special safety procedures to ensure the safety of those who handle them. Most mechanics who work on internal combustion engines often lack the knowledge to work on these electric vehicles. However, these mechanics can work on vehicles that use synthetic and biofuels because they are mechanically identical to normal vehicles. What most normal vehicles do not have, however, are the high voltage components. Mechanics often need special training to handle these high voltage components, as without proper training, these components could be deadly. It's harder and more dangerous for mechanics to handle electric cars compared to synthetically fueled or biofuel cars, where components are basically the same as those in internal combustion engine. Others might claim that biofuels are mostly produced from the global food supply, and if implemented, will disrupt the food supply. This is not untrue, as right now, most of biofuel comes from plants that are consumed by humans. Ethanol, for example, is made from corn and sugarcane, while biodiesel mostly comes from palm oil, which is basically the main ingredient for everyday cooking oil, or the raw ingredient, However, biofuels can be made from virtually any biomass, even plants that are considered useless and invasive, and they even can be made from algae. Research has been conducted on how algae, grass, and some other plants that are not food can be converted into biofuels such as ethanol and biodiesel. With proper research and development towards these other sources of feedstock, it is possible to use biomass that does not disrupt the food supply. So, in this thesis, we've discussed why biofuels and synthetic fuels are a great alternative to electric cars. Biofuels and synthetic fuels are more economically viable compared to electric cars. They are more environmentally friendly compared to electric cars, and they are more practical compared to electric cars. Now, let's all go back to the initial story, where we live in a clean, carbon-neutral world, where that is run by synthetic fuels and biofuels. This is the future that we all can live in if we invest and are serious about biofuels and synthetic fuels. Other than that, we could keep the enthusiasts happy, like me, as they could still hear V8s, flat 6, V10s, and V12 engines singing while also still saving the environment. So what should we, ordinary citizens, do in this regard? We should support the government effort to incorporate biofuels and synthetic fuels into our daily lives. Furthermore, we should educate other citizens about the benefits of biofuels and synthetic fuels, as many of us are oblivious to the potential benefits they provide. After all, maybe Bahlil and Prabowo are not so wrong after all. Their push for biofuel incorporation into our fuels might not be so bad after all, but they might be very beneficial. They're not perfect, but this might be one thing that's good. After all, the future is now. And so if we want to change the future, we should start acting now. Let's start supporting biofuels and synthetic fuel, guys. Thank you. Thank God I'm done.
Not quite done. We've got panelists, Mr. Hans and Miss Christie. We'll start with Miss Christie, since Mr. Hans is just seeing the paper for the first time. Okay.
So my time is 10 minutes, is that right? Okay. So before getting into the question, I just want to appreciate your thesis, Ken. Very nice job on your thesis, on your presentation. Such a good topic, and you are doing a very good research. So good job on that.
Thank you, Miss.
So I'm going to ask some things that I'm curious about. Just chill out. Do not stress out. I'm just going to ask some things that I'm curious about.
Okay.
So I'm not quite familiar with how synthetic fuels are made. So you are saying that the carbon dioxide is being absorbed. Is that right?
It's not absorbed, but the carbon dioxide will be captured by a system. It could be captured from the air, it could be captured from the sea, it could be captured from other carbon dioxide sources, and that carbon dioxide will be captured and then processed with hydrogen, and by the end it will create fuel. But the process is pretty long, and if I were to talk about that process, it will be an entirely different thesis because it's long, it's chemistry, and I have not learned about that much. So if that's all I can give, I'm sorry, but that's basically what happens.
Okay, so you are capturing the carbon and then you are making hydrocarbons because you're using hydrogen, right?
Yeah, that's correct.
And then to finally get the hydrogen, is the process using electrolysis?
Yes.
Yes. So those two processes, the electrolysis and the carbon capture, I'm pretty sure that they require electricity to operate. So you criticize EV because much electricity comes from fossil fuels. But if synthetic fuel also use electricity that comes from fossil fuel during its processing, like carbon capture and electrolysis, do you think that the process itself is still carbon neutral?
If the source of the electricity is from, I said again, fossil fuels, it isn't carbon neutral. However, when producing synthetic fuels, the process has to be carbon neutral. No, sorry. I mean, the process of producing the electricity in itself should be from a source that's carbon neutral. And that is from what I read, there's almost everyone that wants to produce these synthetic fuels will source the electricity from sources that are carbon neutral, for example, wind or solar energy. While if we want to say electric cars, there's no requirement for these manufacturers to source these electricity from carbon neutral sources. That's why we have Indonesia right now. We still use coal power plants. We still use power plants that use diesel engines to produce electricity because there's no mandate on that we need to use power sources that are carbon neutral. However, if it's electrofuels, it will be carbon neutral. And I believe they will take less power compared to charging electric cars.
Okay, so do you have any data about how many electricity that you need to produce synthetic fuels, and then how many energy that the synthetic fuels can produce?
To produce synthetic fuels, if I'm not mistaken, you only need about 20% of the energy that is needed to charge an electric vehicle. And to Are we talking about efficiency of the engine now or no?
Yeah.
If it's the efficiency of engine that runs on synthetic fuels, that's around 50, 60%. So I believe it's much more efficient.
So it's more efficient to produce synthetic fuel rather than charging the electric car directly. Is that right?
That is correct.
Okay. So you mentioned about carbon neutral several times. May you explain again what is the definition of carbon neutral?
Carbon neutral means that the car, in simple terms, this is a car, right? And the car does not like, it still emits carbon, but the carbon will be recycled through the whole process. So if we see the entire process, the car is carbon neutral because it reuses the carbon and uses carbon. It's a cycle.
Is that all?
That's basically the short, yeah.
Okay. So do you think that carbon neutral necessarily mean environmentally sustainable?
I don't think it is necessarily environmentally sustainable, but it is very likely to be environmentally sustainable because carbon pollution is most of the source of our pollution right now today in the world, and it is like the main cause of global warming, among other things. And so if we are able to cut carbon emissions, we will be able to decrease the rate of the environmental damage. But it is still a process. So
in order to be actually environmentally sustainable, we have to reduce the carbon emission.
yes,
Okay. Okay, so you said that EV infrastructure costs trillions.
yes.
How much do you think global synthetic fuel production infrastructure costs at the scale needed to replace gasoline entirely?
It will cost a lot of money, even trillions. However, it is a long-term investment, as after we have built all of these processing facilities to take carbon from the air, we don't need to invest anymore. And we don't need as much investment as electric vehicles because we just need the processing facilities, right? If it's electric vehicles, we need infrastructure, we need everything. We need to produce everything from scratch. However, if it's synthetic fuel, we don't need to produce everything from scratch because there already exists the infrastructure, right? I already said there's the infrastructure to transport, for example. We just need the infrastructure to produce it. And investing in that would not be as much as investing in electric vehicles.
I'm still not quite getting the picture. Could you please explain more about which infrastructure that we already have?
We already have, for example, the refinery, the gas station, the storage facility. If it's for synthetic fuel, it's already there. The infrastructure that is needed to make the synthetic fuel is not yet there. However, if it's electric vehicles, well, you can see like we're starting to build, but we need to build everything. We need to build the power lines to transport the electricity. We need to build the charging cables that is needed to charge the electric vehicles itself. We need to build the new charging stations. We need to build generators and other stuff. We need to build the assembly facilities. But if it's just the synthetic fuels, we just need to build the facilities that are needed to produce the synthetic fuels. And that's it. Because like the infrastructure that is needed to transport it and put it into our cars are already there. So no need. We just need the facility to build it because the cars, they don't need modification and anything for synthetic fuel.
Okay, thank you for your answer. I guess that's all.
Thank you, Ms. Christie. Mr. Hans?
Right. Hello, Kent.
Hi.
Don't worry. Apologies. I don't think I can comment a whole lot about the thesis because I just knew this like this morning.
Oh, thank God.
Thank God. Should I start reading now?
Okay.
Okay. But then regardless, after hearing in your presentation, I can see the effort that you've put into the practice because, I've stick around, you've joined Diamond Club. I've known that you do have a little bit of list, I think everyone can hear, but regardless, you've done a fantastic job in overcoming that hurdle. So kudos to you on that part. Just a little bit more on your presentation. I think you can do better with a little bit more eye contact. I think I can see that
Yeah, I
you tried engaging with the eye contact, but then I see that most of the time you are looking off into the horizons. Like that. I do understand maybe you do
helps
have
me
reasons
focus,
for that.
mister. It helps me focus.
Yes, I'm aware. It sometimes it does help me too, but don't forget to also engage with everyone else. Okay. And in general, just a little bit of comment on, I would say, the presentation that you've done, and also with some of the Q&A. I'm aware that some of these, I would say, are relatively general concepts that people can see, right? Oh, okay, if we need to make something new, then it's clearly not, it's clearly going to be a bit more wasteful compared to using existing things. That's, I would say, it's a general platitude that yes, we do understand. But in these cases, in papers like this, you have put data, that is correct. And I've seen you've also used it maybe in your thesis, it's going to be a whole lot more data, but in your presentation, I do wish you can input a whole lot more, I would say, tangible data to support your arguments. So just a little bit of feedback. And for, I would say, for my first question, I think Ms. Christie has actually taken some of my questions. So to have, I would say, yeah, my first question will be then, maybe this might be your opinion, or maybe you have data on this.
Yes.
Clearly, as of now, the biggest push that we currently experience is clearly EV, right? You go to any car display, you go to any car exhibition, half of it now has probably been turned into like electric cars, EV, instead of cars utilizing biofuel or synthetic fuels. Maybe can you enlighten us as to why is that push is a whole lot bigger compared to this alternative that you've tried to convince us that this is actually a whole lot better. Why do you think the push is now on EV? That's my first question.
The push is on EV is mainly due to government lobbying. It's because, for example, we see in the USA, it's Tesla, and Tesla has been lobbying to make electric vehicles for a long time. And so, well, finally, they make electric vehicles, and they have been trying to convince, oh, electric cars are the future. Electric cars are for the greener world. Electric cars are for the better. Because, well, we just see the electric cars itself, right? The electric cars do not produce any emissions. And so, ooh, that's pretty good. This is the best thing that's going to come out of it. Okay, let's start producing electric cars. However, what they forget to look, however, wait. Well, that is the main point. It's because of the government lobbying. And because the US government have been doing this, and because of recent conflicts and a lot of fuel shortages that, well, makes Pertamina Dex, for example, makes it go from like 12,000 to like 30,000 now. So like it's very expensive. Now like people think, oh, it's better if we just use electric vehicles and substitute everything for electric vehicles. That's mainly why.
All right. Thank you, Ken, for the answer. I do see that, yes, sometimes policy is driven more to those who have interest in it. And if people are interested, well, not people. If the companies are interested in EV, then usually they will push for EV. Thank you for the answer. But then I think I'm going to maybe repeat the same question again because I would like to maybe check whether you have the notes on this or not, especially in the carbon production offset, right? Clearly, when we talk about petroleum, when you talk about fossil fuel cars, the carbon production comes not only from the process, which is, well, obvious with the mining, offshore drilling, and so on. And in addition, the result, the byproduct of the car itself also produces carbon, right? So in general, it would produce more. But then, especially going into our alternatives here, we have EV, we have the synthetic fuels, we have the biodiesel. Do you have access to data on the carbon offset. In general, on the, I would say, in Indonesia we call it hulu ke hilir, like from its production until its usage on the road. Do you have data
Oh
on
yes,
the carbon
I do.
offset?
I do.
Okay, so go ahead.
It's not data, but I give you like the big picture, okay? So first, let's analyze electric cars. Let's see the car in itself. Okay, the car in itself, no emissions. Good, good, nothing. Okay, let's now just see synthetic fuels and biofuels. Oh, the car itself is still producing emission. Okay, maybe not so good. Okay, but okay, now let's see the big picture. How do we make electric car batteries? We need to mine them. We need to dig them up from the earth. And we can only do this in just some places. And what we know what happens when we mine stuff, right? We destroy environments. We release a lot of CO2 gas. We release a lot of gas that is toxic, that is trapped inside the earth for a very long time. And then suddenly go out. Other than that, there's many bad things that happen surrounding it also, to the animals, to the forests, to the plants, to the population that lives around these mines, because around these mines, these are not healthy. And so that releases a lot of CO2 emissions. Okay, so that's the production of the batteries, right? Now let's go to the end of the life, when the electric car get thrown away. Most of the batteries, well, you can recycle them, but it's very hard to be recycled because the materials inside them are lithium, and as we know, lithium is very reactive, and if we just expose it to the air, it will explode, it will combust. So that is very dangerous. And so what do most people do? Well, let's do the easy thing. Let's just throw it away and burn it. More CO2 emission. So in the big picture, that produces a lot of CO2 emission, even millions of metric tons of CO2 emission from everything. However, let's see biofuels and synthetic fuels. Biofuels, the start of life, if it's synthetic fuels, we take the carbon dioxide from the air, from the sea, and from carbon sources. Like, for example, we take them from factories. We take them from cities that have a lot of cars, for example. We take them, we process them, and we make them into synthetic fuels. For biofuels, well, biofuel is this plant. A plant takes CO2 from the air and converts it to sugar, energy, and releases oxygen as photosynthesis. And then from that plant, we process that plant, and we make it into ethanol, or we make it into biodiesel. And then in the end of life, well, it goes out again, and it comes back again. So round and around, so it's a cycle.
All right. Thank you for giving us the big picture. It is a whole lot clearer now. Just a little bit of feedback. This is where I would like to see those tangible data. I think this is where you can improve. Maybe, well, I believe you are going to engineering, mechanical engineering,
Yes.
in UI. I think this is a good practice for you to know which parts of your arguments that will require, I would say, more tangible data. So that's just an example. How many minutes do I have, Mr. Wade?
You've got like 3 minutes.
30 minutes? Oh, 3 minutes. It's like 30 minutes. Oh, wow, fantastic. Right. So I do have just a few more questions, especially on this one. Now, I would like to clarify first, for the engines, right, internal combustion engines, are we talking about, should this be a specific type of engine that will be, I would say, more manageable with the synthetic or biofuel that you've mentioned, or should this engine be a specialized engine that runs specifically on these alternative fuels? So I would say the major question that I would have is, would existing cars, like the cars that we have, like Avanza, Xenix, or whatever, the diesel engines that we have, will they be compatible with the alternative fuels that you've mentioned? That's my question.
Thank you for the question. My answer is they will be compatible. As, for example, if it's diesel engines we're talking about, right? Diesel engines can run on cooking oil. If we just put cooking oil into a diesel engine, it will run. If it's like very, very robust diesel engine, yeah, it will run. So if we put biodiesel on this diesel engine, it will run. And there have been tests conducted by the Indonesian government trying to run diesel on B100 biodiesel, which is basically full biodiesel, no crude oil. And the test has been successful. And now trains that are in Indonesia, they use B50 biodiesel. So, and they don't have like any modifications done to the engine, so they can run. If it's gasoline engine, it's the same thing. They can run, and it's even more powerful compared to the fuel that's previously crude oil, right? The ethanol actually makes the engine more powerful, and it would run better. There only needs to be like few changes just for the fuel tank, and that's it. Because like, for example, ethanol, it likes water. It's hydro. I forget the term, but like it likes water. So it's gonna like corrode the tank is made from metal, it's gonna corrode it. So like we just need to change the fuel tank, and that's it. They're gonna run. Same thing with synthetic fuel, but it's even better because synthetic fuel is identical to the previous fuels and contains even less impurities. So if we put these fuels into synthetic fuel into normal internal combustion engines, like for example, there's in Avanza or in my case, in my Nissan March, it will run. It will run just well, and there will be no issues.
Right. Thanks for clarifying. And I think the term you're looking for is hydrophilic. Is that correct, Ms. Christie?
Hydrophilic.
Hydrophilic. Yeah.
Hydrophilic.
Okay. So you did say that in terms of adaptation, only the fuel tank needs to be changed.
Yeah.
Right. And I would like to just have one follow-up. This will be my last question. You did say the tests are successful, they are actually more powerful, there's little to no side effect. But even besides the ones that you've mentioned, in terms of the fuel tank corroding due to the biodiesel or the alternative fuel filled into the tank, are there any possible, I would say, byproduct or side effects of that change? Anything that has been maybe taken note of, like people have been documenting like these side effects or byproducts for the use of biodiesel or synthetic fuel in these same engines?
For synthetic fuels, no, there have been no recorded byproducts because it's basically identical. It's just fuel. However, for biofuels, other side product is it's slightly less efficient. It's like 5% less efficient compared to normal petrol because, well, it's also more powerful, right? So it's less efficient. And it also like, it still corrodes the fuel tanks, but other than that, well, there's no significant side effects other than that. But I believe that through more research, through more R&D, through more investment, we could eliminate these byproducts and produce biodiesel that's actually identical, and that will be beneficial for the engine itself. So engine needs no change.
Okay, we're out of time, and I cannot ask you about other pollutants besides carbon dioxide in combustion engines. All right, you have passed. Come on up. Kent, we've got meet over here with family and friends.